Hi, everybody. Welcome to the Lights on Data show. I am George.
And I'm Deanna, and today we're diving into industrial AI.
While AI has already made its mark across various industries, I think that its potential is also unfolding in the manufacturing and industrial spaces. How can AI drive productivity, improve operational efficiency, and create more intelligent factories?
Our guest today is Bryan DeBois, the Director of Industrial AI at RoviSys, one of the largest independent global system integrators in the manufacturing industry. With over 20 years of experience in operational technology, Bryan has been at the forefront of implementing AI, data infrastructure, and advanced analytics to revolutionize global manufacturing.
Brian, thank you so much for joining us today.
Yeah, happy to be here.
So, to kick things off, we know that AI is being seen as a game changer in industries like healthcare and finance, but industrial AI seems to have its own unique challenges and opportunities. So, what are those primary drivers, first of all, for pushing industrial companies towards adopting AI?
Yeah, so as you mentioned, industrial AI has really a bigger hill to climb because this is an industry that is very risk averse, as you can imagine. Manufacturing and industrial customers tend to think in terms of decades. When they buy equipment, they want it to last for 20, 30 years.
Right.
Also, they're very averse to any kind of downtime, right? So when they're not making product, they're not making money. And making sure that we can answer those objections and make them feel comfortable with the adoption of AI is really important. Now, some of the drivers, as you mentioned, that we're seeing, one of the biggest drivers that is happening right now, and it's not actually getting a lot of coverage in the mainstream press, but it is a consistent problem when I talk to my customers, and that is what some people are calling the silver tsunami. What that looks like is the experts who knew how to run these plants and how to maintain these plants are retiring, and in very big numbers. LNS Research, which is a research body that covers these types of things, they did a survey, and in 2019, the average tenure for the manufacturing workforce was 20 years on the job. As of 2023, that has fallen to 3 years on the job.
Oh my God.
That's a huge loss of all of that expertise about how to actually manufacture these things. And a big driver that we're seeing is customers coming to me and saying, how can we capture this expertise before those folks leave? So to put it in real terms, I was up in Canada at a vinyl extrusion factory, and I'm talking to the plant manager. And as soon as I get there, he says, I've got two guys who are the best in the world at running this vinyl extrusion line, and both of them are 5 years from retirement. And he's like, I've got no bench. He's like, I've got 6 month and 1 year folks. I've got high turnover in that position. And so once those guys retire, his choices were he can either deal with the fact that the plant will never run as well as it does today, or he can adopt AI and we can actually capture that expertise from his experts before they leave. So number one is the loss of expertise. That's the number one driver that we're seeing. The other thing, though, that I'll say which is a big driver, is that many of these processes have been around now for almost 100 years in some cases, right? Steel manufacturing, glass manufacturing, a lot of these things have not changed in a long time. And so they're well understood and well calibrated, well optimized processes. So in order to get those single and double digit percentage increases in performance that everyone's looking for, everyone's looking to squeeze more production out of these plants, everyone's looking to do more with less. The only way really to get there is to look at a revolutionary technology like AI. The typical types of improvement processes that they've done in the past are just not going to get those types of big percentage improvements that they're looking for. So I would say those are probably the two biggest drivers right now.
Very good drivers and reasons. And the first one, it reminds me of the banking industry as well. That's relying a lot on very old programming languages like COBOL, and all these people are moving a lot into retirement, if not already. And companies are turning into AI to see how can they interpret the code, maybe convert it into something that's a little bit more mainstream, and they're able to find that workforce to supplement.
Yeah, there's definite parallels there.
Yeah.
Absolutely.
So what are the types of AI then that are being deployed in the industrial space?
Yeah, so they're primarily three high-level categories. The first one is what I'll call traditional AI. Now, I know that sounds funny to talk about traditional AI in an industry that is just now starting to get into AI, but the reality of it is that that category of traditional AI really covers technologies that have been in use in the plant floor for 15, 20 years. And those technologies are primarily unsupervised learning, which is anomaly detection. So that's where we can hook up an ML model. It doesn't require any a priori knowledge. It literally just starts monitoring the process, and it will begin to recognize what normal looks like. Mm-hmm. Then when things go abnormal, when they go out of normal, then it can tell you that it's going abnormal. Now, importantly, it can't tell you why. All it can say is things are looking different today than they looked yesterday. So that's unsupervised learning. That's an anomaly detection. The other category under traditional AI is supervised learning, and that is anything that you've heard the word predictive. So if you've heard predictive maintenance, predictive quality, predictive set point, these are basically what we're doing is we're taking large volumes of very clean, very correlated data from the plant floor. We're sending them through an ML model, and it's learning to predict a single value. Now, importantly, that's all it'll ever be able to do is predict a single value. So in the case of predictive maintenance, how many days until this piece of equipment is going to go down? In the case of predictive quality, what's the final quality of this batch going to be? And it can predict it well before the batch is even done being produced, right? But that's supervised learning. So that's typically what people think about when they think about industrial AI is large volumes of data. Let's send it up. Let's train a model to be able to make a prediction. Now, that's traditional AI. The second high-level category is what we call autonomous AI agents. Now, this one is really important because it is, in my opinion, and I've been at this for actually 25 years. I need to update that bio. 25 years I've been working at RoviSys, and what I have not seen any technology that is as revolutionary as autonomous AI agents. So I do think that those are going to be the inflection point. I think that when we look back in history, we'll say, okay, here was the time before we had this technology, autonomous AI agents, and here's the time after. Why they're so revolutionary is their ability to actually make human-like decisions. So we can train these agents, and we can, as part of that training, there's a process called machine teaching. So that's where we actually capture the human expertise. So that's that mechanism to capture that human expertise. It's called machine teaching. But the training process actually looks like we have some sort of a simulated environment. And the autonomous AI agent then, so we simulate part of the manufacturing process. And the autonomous AI agent then can take actions. And the agent will do all kinds of dumb things as it's learning. But then we give it a penalty and a reward. So if it moves closer to the reward and it's doing the right things, obviously we reward it. If it's moving further away from the goal, we penalize it.
Right.
And so over time, by the time it's done training, it takes typically about a day to train. But by the time it's done training, it's like it's run that part of the process for 20, 30 years.
Wow.
It becomes an expert at the process.
Only after a day. That's amazing.
Right. And so that ability to capture that expertise, that ability for it to make human-like decisions is unique to autonomous AI agents. The last category, and the one that obviously is getting all of the press right now, is generative AI. So that, of course, encompasses things like ChatGPT, which if your listeners are familiar, that's a large language model. But then also all the image and video generation tools that you've seen, they're all under that umbrella of generative AI. Now, generative AI obviously is very new. It's very exciting. It's very cool in its ability to replicate human speech and human creativity. However, there's some very big limitations, at least today, in generative AI that really don't make it appropriate to use on the plant floor. And we can talk more about that if you'd like.
Mm-hmm. Yes, please. I think we should.
Mm-hmm.
Well, and I always come across as a generative AI hater when people hear me talk about this, and I'm really not. I recognize the impact that it's having. I use it a couple times a week. I've got a ChatGPT subscription. And so I recognize the value that it's adding, and it's really cool and it's revolutionary. That being said, what we're finding is people are overestimating its decision-making capability and underestimating its limitations. So let's break apart both of those. First off, its decision-making capability, and I'm so glad that they did this. October of last year, Apple released a study that specifically broke down what the limitations are of LLMs to actually do human-like reasoning. And the reality of it is that they are abysmal at reasoning. They couldn't even handle the most basic of mathematical reasoning. The intelligence that we infer in the answers that a tool like ChatGPT gives us is really because of its mastery of the English language, not because of its ability to actually make any decisions.
Right.
So it is a really good pattern matching engine. It can match the pattern of English language and natural language, or in the case of images or videos, it can match patterns that make it look like it's doing human thought and human creative reasoning, but it's actually not at all, not even a little. So as I like to typically say, it's basically like an autocomplete on steroids. It's really good at picking the next word to convince you that it's thinking, but it's really not. In fact, what you find when you look under the covers is autonomous AI is actually the only AI technology that we have that is capable of doing human-like decision making. And that's because it's based on a technology that's almost a decade old now called deep reinforcement learning. And that is actually the only AI that's proven to be able to make those human-like decisions.
Right.
The other thing is about the limitations of generative AI. And some of this has been talked about, but some of it, I still find when I speak to audiences about this, there's people who aren't aware of this, and that's called hallucinations. And the problem with hallucinations, what that is for your listeners, that's when the generative AI makes things up out of whole cloth, just completely makes things up. And the problem with that is that unless you already know the answer, you can't tell the difference between what is real and what has been fabricated. Yeah. Okay, so here's an example of that. This was from last year, and I will admit this was with ChatGPT 3.5. But so I asked it, I said, can you name the 13 dwarves from the Disney classic Snow White? Now, we all know there weren't 13 dwarves, right? There were 7, right? And so ChatGPT goes, oh, yeah, I can do that. And so it lists out a list of 13 names. Now, the first 7 are the 7 actual dwarfs from the movie. The remaining 6 were completely made up. The names sounded completely convincing. If you didn't know any better, you'd say, oh, okay, there it is. There's the list of 13 dwarves. But of course, we know that those last 6 were completely made up. Now, when we're using it to generate marketing copy, or when we're using to generate an email to a colleague, those kinds of things are funny and it's not a big deal. But if we use it on the plant floor, that could kill somebody. If you make things up on the plant floor, that could have dramatic impact. Yeah. And because of those two things, what I'm saying to my customers today is let's keep an eye on it. Let's look into how it can make an impact in the future. But today it's not appropriate to use on the plant floor. And then I pivot them to let's look at technologies that are proven and that are in use today on the plant floor. And let's start to take advantage of those. I'll make one last addendum to that. And that is that if you want to use generative AI to solve some of the knowledge problems that happen in a manufacturing facility, primarily in what we would call the carpeted space in the offices, by all means do that, right? If you want to hook it up to your ERP and you want to pull in data and you want to use it to provide natural language interpretation of data, love it, go for it. But on the plant floor itself, it's not ready yet to be used down there. That's my take on it.
Oh, yeah, that's great advice. And Bryan, I'm very curious, for all these different types of AI models to be able to be deployed in a manufacturing setting, do you need that machinery to be at a certain level? Do you need it to make sure that they are producing sensor data and any other stuff, or does that matter?
Yeah, so it's interesting. Again, when you're talking about deploying an LLM on the plant floor, yeah, you're going to need some kind of GPU. You're going to need some kind of robust hardware to actually be able to run those models. But anything short of an LLM on the plant floor, you really don't need that robust of processing down on the plant floor. So we are typically able to deploy these ML models on the plant floor with just commodity hardware. Edge devices or servers in the control room are more than capable of being able to run these types of, and they're typically neural networks is what we end up deploying on the plant floor. Now, importantly, we absolutely do need instrumentation. We need sensor data coming from the plant floor. That's effectively how these ML models see and react. So we absolutely need that. And we'll get to readiness here, AI readiness here in a minute. But one other point I want to make in terms of deployment is RoviSys differs from departs from some of the other AI vendors in this space, in that we do not think it's appropriate to deploy an ML model that requires a constant connection to the cloud. There are AI vendors in this space who say we'll get everything hooked up in the plant. And as if you guys are not familiar, the plant, what's called the plant control network, is completely isolated from the outside world. And in the best situations, it's actually air gapped from the outside world. But in all cases, there's what's called a demilitarized zone. There's basically a zone with firewalls on either side that disconnects the plant control network from the rest of the world, which is what you want, right? Because you don't want anyone, you can blow up the plant, you could kill somebody. So that's why we keep that part of the plant isolated. We're deploying these ML models in that plant control network in an isolated environment. There are AI vendors who say, here's what's going to happen. We're going to deploy our thing, and then it's going to send a message up to the cloud, and then the AI model is going to live in the cloud. It's going to make a decision. Then we're going to round trip that back to the plant floor. And then the plant control network can take that information and act on it. To me, that doesn't seem like a very serious approach. Again, with my 25 years in this industry, that doesn't seem like a very serious approach to an architecture. We need to be able to deploy these things. We need to have them to be able to run 24/7 on the plant floor, regardless of loss of internet connectivity. That's just an expectation of our customers. And we can absolutely train these models in the cloud, and we do, and because we require that level of compute typically, but then we're going to pull it down and we're going to deploy it into the plant control network, isolated from the rest of the world.
That's great. And yeah, lately when I talk about cloud technologies and like you with Gen AI, people think that I'm a hater on it. I'm not. I think there's so many advantages of it, but for that exact reason that I described there, I think there's so many other advantages that you need to keep in mind to not go into the cloud. Yeah, so I never thought of manufacturing that way, but it makes complete sense. There's so many foreign attacks as well that we're seeing throughout the world, and factories and plants are definitely on the list of targets. So that's a really good reason to have it on
100%. In fact, let me build on that real quick. And I'm not a cybersecurity expert. We actually have a whole team here that does that kind of stuff. However, in 2009, excuse me, we saw the first ever control system virus. So this was a virus that was created to attack control systems, which are the things in manufacturing plants that actually control everything. It was actually made to attack that. Once that happened, that opened the eyes of a lot of companies, a lot of my customers, and they said, we really need to take seriously locking down the plant floor. Previous to that, in the early 2000s, when I was working here, it was the Wild West. Like if you needed a piece of equipment hooked up, someone would just run to Staples and get a switch or a hub or something like that and throw it on the plant network. And so there's been a lot more discipline. There's been a lot more focus on IT helping within those companies to help lock down the plant floor and help design those cybersecurity architectures. But it's so important. And I think we're seeing it more so than ever, because as you mentioned, not only are manufacturers under attack, and again, some of these processes like chemical processes, polymer processes. I heard a story, this was back in the 90s, of a polymer manufacturer where they had a runaway polymer reaction, and effectively what you had left was a crater where the factory was. And they had loss of life and obviously billions of dollars of damage. So these processes can be very damaging, but then you also have terrorist actors as well as state actors that will attack things like infrastructure. So think power generation and bringing down the grid. So there's all kinds of good reasons the cloud is an important part of my clients' architecture story, but it's important to figure out where the cloud plays and also keeping in mind that plant floor has to be isolated.
Now, Bryan,
I'm very curious about something, and I've
Yes.
been thinking about this for the past 10 minutes, I think. I'm going to deviate a little bit, but I'm very curious, and we're going to go back into these more technical details, but I'm wondering how open people are to this. Of course, your colleagues are on board, maybe the people from the clients that reach out to you also, but what about the employees?
Yeah, it's an important question. And so part of that is organizational change management, which has been around for a long time. And it really doesn't change when you talk about deploying a new technology like AI. It's still the same thing. So it's about, first off, it's about getting buy-in right from the beginning. So one of the things that I think is unique about our approach is that we're not a top-down type of organization. We really from the beginning, these projects, we feel like the operators, the supervisors, the folks on the plant floor, the maintenance folks, the folks who are going to have to use the system should be involved right from the beginning in helping to develop it. And that is just doing that is such a huge win and gets that buy-in right from the beginning. But the other thing, part of it is just empathy, right? So part of it is that my company has been working on the plant floor. We've been around for 35 years. I've been here for 25 of those 35 years. We're very good at understanding and empathizing with those folks who actually have to use these systems on a day-to-day basis. One of the things that I talk to my engineers about when we're deploying these systems is I'm like, think about this. We're telling this operator to ignore their years of experience, their decades of sight and listening to the machine, and they'll know like, oh, the machine's running weird today. They'll know just by hearing it. They're smelling the machine like, oh, what is that smell coming? Mm-hmm. Those are the types of senses that they've developed over the years. And we're saying, forget all that and just listen to this AI model and do whatever it tells you to do. That's a tall order. So we understand there's organizational change management that's required there, but we think we do a pretty good job of making sure that everyone's bought in from the beginning. And we've had successful deployments, and those same operators and stuff are thrilled by the results that they get from these.
That's beautiful.
This is music to my ears. Thank you, Bryan.
So, Bryan, at the same time, I feel the other challenge is with the potential legacy systems that some of the these factories, these companies would have. And my assumption is that they do have legacy systems because so many do. And obviously, because of it, they have challenges related to data infrastructure and integration and things like that. And are there any other key obstacles that manufacturers need to overcome when they want to operationalize those AI technologies that you described?
Yeah. And so I mentioned AI readiness. So let's talk about what AI readiness looks like, right? So there are companies who we walk in there and they've already done some of that hard work about building a data infrastructure, and we can leverage that and start to build on top of that. There are companies though and so this, I'll give you an example. So this was a semiconductor manufacturer. And so I gave them the whole AI pitch and they're excited. And I said, now let's pivot and let's talk about your data infrastructure. And they go, we've got a bunch of disconnected work cells and each one has an Access database attached to it. And they're not really networked or anything like that. I'm like, oh boy. And I go, and so then they go, now these AI algorithms, are they able to go and find all that data in all these Access databases and pull it all? I'm like, no, they won't do any of that. So then we have to pivot, and then we've got to talk to them about data infrastructure or AI readiness type of project. Now, it's not to say that you can't take advantage of AI if you don't have this big, robust OT data warehouse already in place. There's some middle ground there, but there definitely is. We're doing more readiness types of projects now than we've ever done in the company's history. That looks like doing industrial network upgrades and getting that infrastructure ready just from a strictly making it secure and making sure that we have access to all the data that we need. We're adding more sensors and instrumentation. One of the other things that's obviously very common in our world are what are called historians. So these are time series databases that live on the plant floor. And we've had them for decades, but they collect all of that high-speed process data that comes from the plant floor. So typically tens, hundreds of thousands of data points in these time series databases. We're now expanding the footprint of those historians to make sure we're capturing more of that data so that we can leverage it in our AI models. And then the cloud finally plays an important role here. Again, I'm not a cloud hater at all. So all that data typically needs to go somewhere. And so many of my customers are saying, look, I don't want a big IT footprint on premise at the plant. Let's go ahead and move all that data up into AWS, into Azure, into GCP, and be able to then, and that just makes our job easier, to be honest, because then again, we're typically doing that training of these models right in the cloud anyway. So it puts it right next to the compute that we need anyway. We have to look at data infrastructure. I'm going on site next week to the UK to talk to a company, and they are looking at rolling out, I'm partnering with an AI vendor, and they want to roll this AI vendor's product out to every single site in their enterprise. And I think they have 30 sites globally. But what I'm going out there to do is that initial AI readiness assessment. And I'm going to be talking to them about here's the steps we have to take to be able to get this data up to actually be able to take advantage of these AI models.
Beautiful. And is that how most engagement starts with RoviSys? So you do that AI readiness, and then next steps is to see what type of AI they should deploy?
I will say this, we're very big on use cases. So actually before any of that, we will have, and actually the first thing on my agenda is to talk about use cases with this customer, because we think that use cases should lead and technology should follow. So let's first talk about here's where we think AI is going to have the biggest impact. Here's where, and we work with the customer to identify, here's the use cases that we think where you can leverage AI and you can get a percentage to double-digit percentage increase on production, or decrease in scrap, right? Decrease in energy utilization, right? All of those things which can lead to millions of dollars every year. We identify those use cases first. Then we work backwards on, okay, now here's the AI readiness that's going to be required. Here's the data that's going to be required. And here's the AI algorithms that are going to work the best for that. So that is where we start, is more on the use cases.
I'm curious, Bryan, so you have so much experience. You've seen so much evolution of the technology throughout your life. For the people listening, if anyone would like to get into this field, what background should they have, or what should they look more into?
Yeah. Well, if they want to get into manufacturing and industrial specifically, obviously engineering or computer science are the way to go. So my background was computer science. I actually, before I started at RoviSys, I knew nothing about manufacturing. But I did love the show. If you guys have ever seen the show How It's Made,
Yeah.
that shows the inner workings of factories, I loved that show. And now it's so fun because now I get to live it. Now I get to go into these factories and see it all firsthand. So it's pretty cool. But yeah, a computer science background or an engineering background are typically the way to go. From there, I can tell you what I look for in resumes. If you can get into a manufacturing company and do an internship in a manufacturing company, that's going to be so key and such a differentiator if you can do a co-op or an internship at one of those manufacturing companies. Because I know then when I'm looking at that resume, that's somebody who actually understands a plant, has been in a plant, has seen the challenges that are typical in those types of environments. And so we're not starting from complete scratch and getting that person up to speed.
Yeah.
Lovely. Lastly, Bryan, is there any advice that you like to provide to industrial leaders who are just beginning to explore AI and its potential benefits to their operations?
Yeah. And so I get that question a lot when I speak at trade shows and things like that. And so here's typically where I go. I say, one is you need to take the first step. And here's why. Just because you think maybe you're not ready as an organization to take advantage of AI, your peers are, because I'm probably working with some of them. So the other folks in your industry are taking that first step. So you need to take the first step. Now, that does not mean that you need to go and do a full AI deployment tomorrow, okay? But at least do some of those readiness things, right? So that when you do feel like it's time to start to take advantage of AI, your infrastructure, your data is in a place where you can actually feasibly be able to take advantage of some of those things. And the last thing that I typically say, and I know it sounds self-serving, but get a system integrator involved. Our goal, because we're not a vendor, vendors have a hammer and everything to them has to look like a nail, right? We're an independent system integrator. We don't have a horse in the race. So we're happy to work with any vendor and we'll bring the right vendors in. But we do, I think, a good job as system integrators in breaking through some of the hype and some of the fear, uncertainty, and doubt that those vendors create, to be honest, because it helps them sell product. We're able to cut through a lot of that hype and right size the solution to that customer. So I do recommend that they get a system integrator, preferably a system integrator that focuses on industrial and plant floor, not just some big name, one of the big IT consultancies. They're fine. But for this type of work, find somebody who's familiar with the plant floor and lives it every day, like a company like RoviSys.
That's right. Bryan, how can people find you?
Yeah, they can find me on LinkedIn. That's probably the easiest way to find me. It's Bryan DeBois, and it's right there on the screen. So just search for that on LinkedIn or look up RoviSys.com. So that's ROV as in Victor, ISYS.com. That's my company. And yeah, happy to connect with anyone on this.
Thank you.
Thank you very much. Thank you, Bryan, for your time. Thank you for sharing all this knowledge, experience, and wisdom with all of us. Thank you very much, everyone, for listening, and we'll see you soon.
Bye, everyone.